In Beijing, a highway bridge that carried more than 200,000 vehicles a day was replaced in roughly 43 hours. That number is not a metaphor. Traffic was diverted. The old structure was cut into 27 prefabricated segments, the heaviest weighing about 139 tons, and a new bridge weighing roughly 1,300 tons was rolled into place on multi-axle transporters and aligned to millimeter tolerances. By Monday morning, commuters were back on schedule. The viral takeaway is speed. The harder question is why that speed is possible, and what it actually proves. Start with the obvious explanation that gets skipped in most videos. China spends far more on infrastructure than the United States, and it has done so for years. Independent estimates put annual infrastructure investment at roughly 6 to 8% of gross domestic product through much of the last decade. In the United States, public infrastructure spending has hovered closer to 2%. When you fund more projects, you also fund the factories, the crews, the transporters, and the learning curve that turns one impressive replacement into a repeatable playbook. Speed is not magic. It is capitalization. There is also the matter of standards. The SanYuan Bridge replacement was not a bespoke art project. It was modular. Prefabrication meant the work happened off-site, under controlled conditions, while traffic kept moving. When the window opened, crews executed a choreography they had rehearsed before. The equipment was owned or reserved in advance. The tolerances were known, and the authority to shut lanes and move freight did not require years of public hearings. None of that diminishes the engineering. It explains it. Contrast that with the American reality. The latest National Infrastructure Scorecard raised the United States to a solid C, an improvement from the previous C-. That progress is real. Federal funding increased, and some backlogs are easing. But the structural problem remains. Major transportation projects routinely spend a decade or more in permitting, litigation, and procurement before a shovel touches dirt. By the time construction begins, costs have inflated and designs are compromised to fit what is left of the budget. American engineers are not slower. American projects are older before they are born. This is where the China comparison gets abused. The Beijing Bridge example is presented as proof of superior talent. It is better understood as proof of a system that prioritizes execution over process when leaders decide a project matters. That trade-off has benefits. It also has costs. Fewer veto points mean fewer delays, but they also mean fewer chances for local communities to object, fewer opportunities to change a design midstream, and fewer legal breaks if something goes wrong. Speed is a choice. There is another factor that rarely gets airtime: maintenance versus replacement. The SanYuan Bridge was replaced quickly because replacement had been planned and funded. In the United States, agencies are often forced to stretch aging assets far beyond their design life because maintenance budgets get raided to plug other gaps. When a bridge finally must be replaced, it is an emergency layered on top of deferred upkeep. China's model front-loads capital to avoid that trap. America's model postpones pain until it becomes unavoidable. Then we act surprised by the bill. The viral clips also omit the cost context. Rapid replacements require fleets of specialized transporters, heavy lift cranes, and a supply chain that can deliver massive components on command. Those assets are expensive. They make sense when they are used frequently across many projects. They make less sense in a system where large replacements are rare because funding arrives in bursts. China amortizes speed across volume. The United States buys speed one project at a time, if at all. None of this should be read as an argument that America should copy China wholesale. The United States values transparency, environmental review, and local consent for good reasons. Those values slow projects down, and they also reduce risk in ways that are hard to quantify in a highlight reel. But it is fair to say that the pendulum has swung too far toward paralysis. When a bridge replacement that could be executed in a weekend takes years of paperwork, the problem is not engineering, it is governance. The Beijing Bridge replacement also reveals something uncomfortable for American audiences. When China decides a project is essential, it aligns money, authority, and logistics behind that decision. In the United States, Those elements are fragmented across agencies and jurisdictions. Each fragment has a veto. The result is not safety, it is drift. We end up paying more to get less, and we congratulate ourselves for the delay. So what shocked American engineers watching that 43-hour replacement was not the math. It was the permission. Permission to standardize, permission to prefabricate, permission to close roads decisively, and permission to treat construction as an industrial process rather than a bespoke negotiation. That permission does not come free. It is purchased with political trade-offs that Americans have historically rejected. The question is not whether we can build faster. It is whether we are willing to decide when speed matters, and to pay for it honestly when it does. The second viral example usually comes packaged as a slogan. A railway project completed in 9 hours. What actually happened in Longyan, Fujian province, was more precise and more revealing. Crews replaced and upgraded a critical section of track and signaling near an active station during a tightly controlled overnight window. Trains were halted, teams moved in by the thousands, prefabricated components were dropped into place, systems were tested, and service resumed before morning. The headline says, 9 hours. The lesson is everything that happened before those 9 hours ever began. By the end of 2023, China's high-speed rail network had reached roughly 45,000 kilometers in operation, more than the rest of the world combined. That scale matters because it creates repetition. Stations, tracks, switches, and signaling systems are standardized. Crews train on the same configurations again and again. Suppliers build to known specs. When an upgrade window opens, there is no debate about which bolt fits which plate. The work looks miraculous, only if you ignore the years spent removing uncertainty. Funding explains the rest. In 2023 alone, fixed asset investment in China's railway sector reached approximately 764.5 billion yuan. That money did not just buy concrete and steel. It bought inventory buffers, spare components, and standby labor. It bought the ability to mobilize 1,500 workers for a single night without scrambling for contracts. In American terms, it bought optionality. When something needs to be done fast, the pieces are already paid for. The United States runs the opposite model. Rail upgrades compete for funding with highways, transit, ports, and airports. Assets are customized by region, vendor, and era. Even when money is approved, procurement rules stretch timelines and discourage stockpiling. As a result, work that could be compressed into a narrow window expands to fill months or years. Crews do what they can during limited shutdowns, then leave and return later. The inefficiency is not in the labor. It is in the stop-start rhythm, imposed by budgeting and oversight. Supporters of the Chinese model point to travel time savings as proof of success. Routes that once took 7 hours now take 90 minutes. That is real value for passengers. Critics point out that not every line earns its keep. Both can be true. Research on infrastructure returns shows that early high-speed corridors delivered strong economic benefits, while later expansions into less dense regions produced diminishing returns. Speed, in other words, scales faster than profitability. The Longyan project also highlights a cultural difference in how disruption is managed. In China, overnight shutdowns are treated as a civic inconvenience that serves a collective goal. In the United States, even short service interruptions can trigger political backlash and legal challenges. Agencies respond by minimizing closures, which stretches projects over longer periods and inflates costs. The irony is that the attempt to avoid disruption often creates more of it, just spread thinly over time. There is a tendency in American media to frame these stories as a referendum on national competence. That misses the point. The 9-hour upgrade was not about genius engineers working miracles. It was about a system designed to concentrate risk and effort into short, intense bursts. That system accepts that something might go wrong, and it prepares redundancies accordingly. The American system distributes risk by slowing everything down. Neither approach is morally superior. They reflect different social contracts. For an American audience, the uncomfortable takeaway is this: speed is not an outcome you order at the end of a project. It is a feature you design into the entire pipeline. China's rail program shows what happens when design standards, funding cycles, labor organization, and political authority are aligned around execution. The United States could replicate parts of that alignment without abandoning its values, but doing so would require admitting that delay is not free. It has a cost, and that cost is paid in missed opportunities long before the first train ever leaves the station. The Hong Kong-Zhuhai Macau link is often introduced with a single number, 55 kilometers, followed by a dramatic pause. Bridge, tunnel, artificial islands, typhoons, shipping lanes, environmental constraints. It sounds like a checklist designed to impress. The reality is more interesting when you strip away the hype and look at what the project actually required to function at all. This was never just a bridge. The Pearl River Delta is one of the busiest maritime corridors on Earth. Closing it was not an option. That constraint forced engineers to combine long viaducts with an immersed tube tunnel of roughly 6 kilometers, connected by man-made islands. Each tunnel section was cast off-site, floated into position, sunk with ballast, and aligned underwater. That process is not fast by accident. It is slow by design until it suddenly looks fast at the very end, when the last pieces lock together. This is where many viral videos lose credibility. They toss around extreme figures for segment weights or installation times without clarifying units or context. In serious reporting, those numbers matter. What can be verified is the method. Standardization of segments, controlled casting yards, precise marine positioning, and a construction schedule built around weather windows and shipping traffic. The achievement is not that China defied physics, it is that the project accepted physics early and organized everything else around it. Cost tells the other half of the story. The link carried a price tag measured in tens of billions of dollars. That figure is rarely emphasized in short videos, but it matters for any honest comparison with the United States. American megaprojects face ballooning costs because delays are expensive. The Hong Kong-Zhuhai Macau project faced enormous upfront costs because redundancy and control were built in from day one. You pay either way. The difference is when and how the bill arrives. Environmental trade-offs also tend to get compressed into a single reassuring sentence. The project included mitigation measures for local marine life, including the endangered Chinese white dolphin. Those measures were real, monitored, and controversial. They also illustrate a broader pattern. In China, environmental mitigation is often treated as a parallel track that must keep pace with construction, not a gate that construction must pass through before it begins. That choice accelerates timelines, but it also shifts risk to monitoring and enforcement after the fact. For an American audience, the lesson is not that the United States should bulldoze objections and move on. It is that clarity matters. The Pearl River project had a single overriding objective: connect 3 economic hubs directly. Once that objective was set, design and authority followed. In the United States, objectives often compete with each other inside the same project. Mobility, local impact, cost containment, climate goals, and legal defensibility all pull in different directions. The result is compromise layered on compromise, and timelines that drift. The bridge tunnel system also reveals why comparisons based on speed alone are misleading. This was a multi-year effort that culminated in a visible finish line. When the final connections were made, it looked sudden. It was not. Years of preparatory work were simply invisible to the camera. The same is true of many American projects, except the invisible phase is dominated by paperwork rather than fabrication. What shocked outside observers was not that China built something large. It was that it delivered a complex, hybrid solution without redesigning it halfway through. That stability is rare in systems where political leadership changes frequently and projects are reopened for review. The Hong Kong-Zhuhai Macau link shows what happens when scope is locked early and defended aggressively. It also shows the cost of that discipline, in money, in flexibility, and in public debate. If you want a sober takeaway, it is this: mega projects succeed when uncertainty is pushed to the front and paid for up front. China does this with capital and authority. The United States does it with time and process. Neither method eliminates risk. They just choose different currencies to spend. When the script shifts from transport to energy, the tone usually turns reverent. Baihetan and the Three Gorges are introduced as monuments, turbines the size of buildings, output measured in tens of thousands of megawatts, and annual generation tallied in tens of billions of kilowatt-hours. Those numbers are real, but they only tell half the story. The other half is what projects like these do to a power system, a budget, and a society over time. Baihetan's installed capacity sits at roughly 16,000 megawatts, delivered by 16 turbines, rated at 1,000 megawatts each. Annual generation is often cited at more than 62 billion kilowatt-hours. On paper, that is clean energy at industrial scale. It smooths peak demand, reduces reliance on coal during certain seasons, and gives grid operators a powerful balancing tool. In a country with enormous regional disparities in supply and demand, that matters. The same logic applies to the Three Gorges, which for years has been the world's largest hydropower station by capacity. In 2020, it set a production record of more than 111 billion kilowatt-hours. That output stabilized downstream grids and enabled long-distance transmission to coastal manufacturing centers. From a systems perspective, these dams are not just generators. They are anchors around which transmission planning, industrial zoning, and flood control policies are built. But scale cuts both ways. Hydropower projects concentrate risk as effectively as they concentrate output. Construction required relocating more than 1 million people, reshaping ecosystems, and committing to decades of maintenance on structures that cannot be easily modified once complete. Environmental impacts do not end when the turbines start spinning. Sedimentation, biodiversity loss, and seismic concerns persist, and mitigation costs accrue quietly year after year. There is also the fiscal dimension that rarely appears in viral explainers. Megadams are capital-intensive upfront, and their financing is often intertwined with local government balance sheets. International financial institutions have repeatedly warned that infrastructure-related liabilities at the local level in China are large and opaque, depending on how they are counted. Hydropower can generate steady revenue, but it does not immunize a region against debt stress if broader economic conditions shift. For American viewers, the contrast is striking. The United States has hydropower assets of its own, many built decades ago, but new large-scale dams are politically and environmentally untenable. Energy strategy has shifted toward incremental additions: wind, solar, storage, and grid upgrades. That approach spreads risk and avoids mass displacement, but it also lacks the drama and the immediate punch of a single massive project. Progress looks slower because it is distributed. This difference feeds the perception gap that the original video exploits. China appears decisive and bold, while the United States appears hesitant. In reality, both systems are optimizing for different constraints. China uses scale to force rapid transitions in capacity. The United States uses diversification to manage uncertainty and public consent. One produces landmarks, the other produces portfolios. The uncomfortable truth is that neither approach is free. Large dams lock in decisions for generations. Distributed energy locks in complexity and coordination costs. When commentators marvel at Baihetan's numbers, they are really reacting to clarity of choice. Someone decided that this project would happen, accepted the consequences, and moved on. In the United States, those consequences are debated exhaustively before a decision is made, and often again afterward. So the energy megaprojects do not prove that one country is smarter than the other. They prove that priorities differ. China is willing to pay environmental and social costs upfront to secure scale quickly. The United States is willing to accept slower gains to preserve flexibility and accountability. Engineers understand this trade-off instinctively. The shock comes from seeing it executed so visibly, and from recognizing that the price of hesitation is not zero. It is just paid in smaller, quieter installments over time. The Huoshenshan Hospital is often treated as the ultimate mic drop. 10 days, 1,000 beds, tens of thousands of square meters. Live-streamed construction. For many American viewers, it looked like proof that China could simply will infrastructure into existence. The reality is more instructive, and far less mystical. Huoshenshan was not designed from scratch under pressure. It relied on a prefabricated modular system that already existed. Panels, utility cores, ventilation units, and isolation layouts were standardized in advance. Digital models were shared across contractors in real time. When construction began, more than 7,000 workers were organized into tightly defined tasks, operating around the clock. Trucks moved on priority routes. Materials arrived in sequence, not in bulk. The site functioned less like a traditional construction project and more like a logistics operation. This distinction matters. Speed came from preparation, not improvisation. The 10-day timeline worked because quality expectations were narrowly defined. The hospital was built to handle a specific emergency, not to serve as a permanent, multi-decade facility. That choice reduced design debates and inspection layers. It also accepted trade-offs in durability and flexibility that would be unacceptable for a conventional hospital. The project was fast because it was purpose-built for crisis conditions. Compare that with how emergency construction works in the United States. Field hospitals can be deployed quickly, and during recent crises, they were. But permanent structures face a web of licensing, liability, and reimbursement rules that do not disappear in an emergency. Even when political will exists, institutional inertia remains. Agencies must coordinate across federal, state, and local lines. Private operators must agree on who pays and who is responsible if something fails. The result is caution layered on urgency. There is also a cultural difference in how visibility is used. Huoshenshan was live-streamed around the clock. That transparency was performative, but it was also disciplinary. When millions are watching, delays are harder to hide. Mistakes are corrected immediately. In the United States, public works are rarely exposed in that way. Oversight happens through reports and hearings long after the fact. Accountability is slower, and so is correction. Critics rightly point out that emergency speed is not a sustainable model for everyday infrastructure. That is true. What Huoshenshan demonstrates is not how to build all hospitals, but how to mobilize a construction ecosystem when normal constraints are temporarily suspended. It shows what happens when permitting, procurement, and coordination are collapsed into a single command structure. The cost is that individual objections and refinements are sidelined. In a crisis, that trade-off is often accepted. Outside a crisis, it becomes controversial. For an American audience, the sharper lesson is about readiness. China could build Huoshenshan in 10 days because it had already invested in modular systems, digital coordination, and surge capacity. The United States tends to invest after a failure exposes a gap. That pattern produces resilience eventually, but it rarely produces speed on the first attempt. When speed is demanded, the system has to be bent, not activated. There is also a quieter economic point. Rapid emergency builds do not come cheap, even if the bill is not itemized publicly. Overtime labor, priority logistics, and redundant supply chains cost money. Those costs are easier to absorb in a system where the state can reallocate resources quickly and where losses can be socialized. In the United States, such costs trigger audits, lawsuits, and political backlash. The incentives push decision-makers toward delay rather than acceleration. Huoshenshan, then, is best understood as a demonstration, not a template. It demonstrates how far modular construction and centralized coordination can be pushed under extraordinary conditions. It also demonstrates the limits of comparison. The United States does not lack the technical ability to do something similar. What it lacks is a standing agreement on when it is acceptable to bypass normal processes, who bears the risk, and how the costs are justified after the emergency passes. That is why the hospital shocks American engineers. It compresses into 10 days what in the United States would be spread across months of planning, debate, and negotiation. The compression feels like genius. It is really a political decision executed competently. Whether that decision should be normal or exceptional is a question of values, not capability. When the story moves beyond China's borders, the tone shifts again. Projects like the Marlowe Dam in Sudan are presented as proof that China can export its construction prowess anywhere on the planet. A massive structure on the Nile, new turbines, extended transmission lines stretching roughly 1,500 kilometers. The implication is that Chinese firms do abroad what others hesitate to attempt at home. The reality is more complex and more revealing about how these deals actually work. Marlowe followed a familiar pattern. Chinese state-owned enterprises delivered engineering, procurement, and construction as a single package. Financing was bundled alongside the build, often through state-backed lenders. Equipment, contractors, and timelines were integrated under one command. For host countries, this model is attractive. It reduces upfront uncertainty and promises visible results. For China, it exports industrial capacity and keeps domestic firms busy when growth slows at home. The numbers are substantial. The dam added more than 1,000 megawatts of generating capacity and required extensive upgrades to the surrounding power grid. That meant not just concrete and turbines, but long-distance transmission infrastructure to carry electricity to population centers. On paper, this is development. Lights turn on, industries expand, and governments can point to a tangible achievement. But financing is where the shine dulls. International financial institutions have repeatedly warned that infrastructure loans tied to mega projects can strain public finances, especially when revenue projections fall short. In China's case, concerns extend inward as well. Estimates suggest that local government-related debt linked to infrastructure may exceed 50% of national gross domestic product, depending on how off-balance sheet obligations are counted. Exporting the model does not make those risks disappear. It extends them. For American audiences, this is a crucial counterweight to the original narrative. The shock is not that China builds big things overseas. It is that those builds are inseparable from credit. Chinese firms are competitive not just because they can pour concrete quickly, but because they arrive with financing in hand. Western contractors often lose bids not on engineering, but on the balance sheet. Speed is paired with solvency, at least in the short term. There is also a geopolitical layer that videos tend to glide past. Infrastructure projects create long-term relationships. Power plants, dams, and grids require maintenance, spare parts, and technical expertise for decades. That dependence can translate into influence, whether intentional or not. Host countries weigh that influence against immediate needs. The calculation is rarely ideological. It is practical. This is where comparisons with the United States become uncomfortable. American firms excel at high-end engineering and project management, but they operate in a fragmented financing environment. Export credit exists, but it is cautious, slow, and often tied to political conditions. As a result, American involvement skews toward advisory roles rather than turnkey builds. The outcome looks like hesitation, even when it is the product of a different risk calculus. Marlowe illustrates the central trade-off of China's outward push. By bundling construction and finance, projects move quickly from concept to reality. By doing so, they also concentrate financial risk and political exposure. When growth is strong, that model looks unstoppable. When growth slows, the same commitments become constraints. So the foreign megaprojects do not simply demonstrate engineering dominance. They demonstrate a willingness to treat infrastructure as an export industry, backed by national balance sheets. That strategy has delivered results across Africa, Asia, and the Middle East. It has also generated unease among creditors and partners who worry about long-term sustainability. For American engineers watching from the sidelines, the shock is not technical, it is structural. The question is not whether the United States can build dams or power lines abroad. It is whether it is willing to package engineering, capital, and political risk into a single offer, and to live with the consequences when projects underperform. China has answered that question with concrete. The rest of the world is still debating the terms. The final example, in the original script, looks almost trivial at first glance. A tunnel, only 173 meters long, carved through Lues soil in Gansu province, taking nearly 6 years to complete. Compared to bridges spanning oceans and dams powering cities, it sounds like a punchline. In reality, it is the most honest case study in the entire lineup. The Huming Tunnel was not slow because of incompetence. It was slow because the ground itself refused to cooperate. Lues is unstable, highly porous, and prone to collapse when saturated. Every meter advanced risked failure. Crews reportedly progressed at roughly 2 to 3 meters per day, sometimes less, with constant reinforcement and monitoring. More than 1,000 workers rotated through the site over years, not because the project was mismanaged, but because physics does not negotiate. This matters because it breaks the spell that viral mega-project videos rely on. China is not fast because it ignores reality. It is fast when reality allows it, and stubborn when it does not. The same system that replaced a bridge in 43 hours accepted a 6-year slog for a tunnel shorter than 2 football fields. That contradiction is not a weakness, it is the point. For American viewers, this should feel familiar. The United States also has projects that move quickly when conditions align and stall when geology, weather, or legal constraints intervene. The difference is not that China defies limits while America respects them. The difference is how each country frames success. China showcases speed when speed is possible. America fixates on process, even when speed would be rational. Seen together, all 7 cases tell a more balanced story than the original shock narrative. China's megaprojects succeed because of scale, standardization, centralized authority, and a willingness to front-load cost and risk. They also generate debt, environmental strain, and long-term obligations that are easy to minimize in a highlight reel and hard to manage over decades. The United States, by contrast, disperses risk through procedure, local consent, and litigation. That reduces certain failures and amplifies others. It trades spectacle for resilience, and then wonders why it looks slow on camera. The uncomfortable truth for American audiences is that neither system is broken. They are optimized for different fears. China fears stagnation and lost momentum, so it builds aggressively and deals with consequences later. The United States fears irreversible mistakes, so it delays decisions and pays quietly for inaction. Engineers understand both instincts. Politics decides which one wins. So if American engineers are shocked by China's projects, it is not because they do not understand the math. It is because they recognize a mirror held at an angle. The question is not whether America should build like China. It is whether America is honest about what it is willing to trade for speed, and what it is already trading away by refusing to choose. Thanks for watching, and if you have thoughts on whether speed, caution, or some uneasy mix of both should define the future of infrastructure, let us know what you think in the comments.